111, mic check. Hello everyone, hopefully you can hear me properly. My name is Michael, I'm from LED Strip Studio, and today I would like to talk about our little gadget, which is called, and maybe we can switch the camera view to top down, SPI Lamp. A great little gadget with which you can make your installation process a lot faster, a lot easier, and in the end, a lot cheaper. I would like to ask you to let me know in the chat to my colleague Ben whether you can hear me properly. Last time there was a little bit of a delay with the audio, was not totally in sync with the video. Hopefully this time it is solved and you can hear me properly. And let's check one more thing. Yes, if you have any questions, please let me know in the chat. We will answer them as soon as possible. You can ask really anything in regards to the SPI lamp, so the topic that I will be talking about, or to our controllers. If you want to watch some of our previous online training sessions, go to our YouTube channel. There you can find from 3 weeks ago I was talking about our software, how to do the mapping, how to connect your controllers to the network, and how to basically work with that piece of program. Last week I was talking about the hardware, our pixel controllers, LEC3 SPI Matrix Reactivo and SPI LED controller, and you can go check that out. This time I will be talking about SPI Lamp. Next week I will be talking again about software, but about ArtNet. How to calculate the pixel strips or the pixels with ArtNet, how to work with that part of the software, which is perhaps for those of you who don't want to work with our devices, but they like our software. So, is there any question now, Ben, in regards to what I'm going to talk about? Probably not. Everyone can hear me properly, there is no delay. I think, but without further ado, we can start about the SPI Lamp. Great little gadget. It does a couple of things for you. Mainly what it is doing, it is allowing you to connect two different segments without the need to connect the ends of the strips. If we will switch to top-down camera, I will show you that I have 4 SPI lamps here on the table. And as you can see, the end of the strip from the second or to the second SPI lamp is not connected to any strip that is either next to it or before it. This is a great advantage which can save a lot of time during the installation process. You don't have to lead wires from one end of the strip to another, and thus you are saving the cost and reducing the amount of wires that you actually need. Second thing that it does, and we can switch the camera again, second thing that it does, it multiplies your outputs. I have SPI Matrix here, which is great pixel controller, and you have 4 outputs available on this device. For some project it is enough. However, there are some cases, some use cases, some projects where 4 outputs are simply not enough, and you don't want to, or you can't really have another controller on your project. Then SPI Lamp is a great little gadget for you because you can multiply your outputs basically. On a single output you can connect a lot of SPI lamps in a daisy chain. So in theory you can make up to or create up to 344 outputs from a single device, which again can save you some costs for the controllers, for the labor, and overall it can speed up the process of the installation. You don't have to think about places and placements for multiple controllers, but you only have to place the SPI lamp somewhere, which is a great advantage for any kind of installation, whether it is a permanent one or something that is temporary, let's say for an event or something like that. In addition to these 2 features, it can also power up your strip. So if you will check the SPI lamp and the connection, I can move this a little bit. You can see that I have this wire connected to my connector, and this is providing the power for the SPI lamp and also power for the strip. The total throughput of the SPI lamp is the same as for the output on the LEC3 or SPI matrix, and that is 5 amps. If you want to connect more than that onto your output, you have to use separate power sources. More about the technical specification about the SPI lamp. As I said, the total throughput is 5 amps for the output. Maximum controllable pixels is set to 1024 for RGB pixels or 768 for RGBW pixels. This can change with the IC that you are using. So there are some strip types, some ICs where you cannot use the maximum of 1024 pixels. Rather, you can use a smaller number of pixels. If you want to find out this information, you can go onto our page. And there is a list of supported ICs. And as you can see, there is an SPI lamp in 2 versions. This is mostly for those, or information for those that bought an SPI lamp previously, like maybe half a year ago, a year perhaps. A new firmware version on the SPI lamp allows you to use more different ICs. As you can see, for example, on this IC over here. The SPI lamp, I mentioned this already, but perhaps I can repeat it, is available to use with LEC3 and SPI matrix. You cannot use it, and we can maybe switch, you cannot use it with the small controllers are active or SPI LED controller. The reason for that is it is receiving from the LEC3 differential symmetrical data. We are using our own custom protocol to send the data over an Ethernet cable to your SPI lamp. And then you can use the same Ethernet cable to daisy chain multiple SPI lamps in a row. An advantage of an Ethernet cable is that it's relatively cheap, available mostly everywhere. You can buy it in every second store, which specializes in, say, computers, or any kind of store for that matter. So that is why we've opted for the Ethernet cable, which is perfect to transfer symmetrical differential data over long distance, because there are 8 twisted pairs, and those will allow you to send the data over the long distance. There is a version of the controller, both LEC3 and SPI matrix, which has, instead of, and we can switch to top down, instead of an Phoenix connector for the output that you can see here, there is an RJ45 port. This is available on request, especially aimed for those clients who want to work with SPI lamps. They are 100% sure that they will be working in their project with an SPI lamp, so they can, on a request, ask for a controller which will have, instead of Phoenix connectors, RJ45s on outputs. And that way you don't have to manufacture a connector or a cable, but you can use the Ethernet cable straight from the package as it will arrive. Of course, if you already have an LEC3 and you want to incorporate some SPI lamps in your project, we have an extensive manual that is available online, where, for example, you can also check what is the, and we can switch to the computer, where you can check the diagram how to create your own cable for SPI lamp to receive the data. There you can see which pairs you ought to use and where to connect them. This is the back of LEC3. It's identical to SPI matrix. It is important that you will use data A and data B, so these two pins. You are not powering the SPI lamp through the output, you are only sending the data from the controller to your SPI lamp. Further, and I have this here, well, I can show you how the SPI lamp looks, the PCB I mean. There are two RJ45 connectors. Those are to receive the signal and send it to your next SPI lamp. These two are interchangeable, so you can mix them up and you don't have to really worry about whether the signal will be able to go through that SPI lamp to your second gadget. It will work. However, there is a marked input, which is this one, and a marked output. So if you will use it as such, it will work, but don't worry, you can even interchange them. There are two mounting holes that you can use to place the SPI lamp wherever you need. If you need to protect the gadget against the elements, you can always use this very simple electrical box. As you can see, the design is so that you are able to fit it inside this little electrical box and you can protect it against the elements such as wind, rain, and it will last. In addition to that, there is a dip switch on the SPI lamp, and the dip switch is setting up how many pixels you have connected to your gadget. So if I want to set, for example, I have 3 pixels connected to my output, I will set pin 1 and 2, hopefully my math is correct, and now I'm telling the SPI lamp there are 3 pixels connected to my output. So the signal will come in, light up the 3 pixels and continue to next SPI lamp. You can power the strip through the SPI lamp, and but you have to be aware of the limit that I mentioned already several times, 5 amps per output. In case you will need more, you have to use a separate power supply. So we have a visitor, but we are online, so we can't really help them. Perfect. As I mentioned, we are using our own custom protocol to send the data. So if I want to show you the LED Strip Studio software, we can switch to the PC. I have done this simple mapping, not very nice one, but you get the idea. There are 4 SPI lamps and 4 strips. Each, as you can tell by the curved LEDs, has a different length. I have 300 pixels connected to my first SPI lamp, 25 on the second, etc. How you can work with the SPI lamp with the software? Well, you have to create a group. I recommend to go to our YouTube to check out the software tutorial where I explain in detail what are groups and how they work. It is very important that for whenever you are using SPI lamp, you create a group from your segments. A group means that you are using first output. So group 1 is output 1 basically. And for the group, you have to set what IC you are using. Normally you would use an IC of the chip that is on the strip that, for example, the producer provided, but in this case you are using LED Strip Studio RGB or LSS RGB. That way it will start to send the symmetrical differential data from the controller to your SPI lamp, and then SPI lamp is translating those data to data that the strip can actually understand. Are there any questions, Ben, by any chance? Not yet? Okay, great. When I'm talking about the differential data and symmetrical data, perhaps some of you are aware or know some of our other gadgets, and they know that there is a little thing that we call the symmetrizer. And this one is a little bit outdated, but you perhaps get the idea. Symmetrical data comes in from the LEC3 or SPI matrix, and normal data, TTL level, I think it is called, are going out to the strip. This little gadget, the symmetrizer, is already built into your SPI lamp, and one is built in LEC3. So that is why you don't need an additional symmetrizers or additional gadgets when you are using the SPI lamp, which is another additional value of the SPI lamp. You can always send the data over long distance. I've got a bunch of, and I wonder whether you can guess how many meters of Ethernet cable you can use. I have only these short pieces here, but you can always use something like 25 meters of an Ethernet cable, and it's not really a big distance for the SPI lamp. If I will unplug this, are we on top down? You can notice that there are some LEDs on the SPI lamp. Green one means that the SPI lamp has power. Yellow one, if it's not blinking, means that it is receiving signal and translating it for the strip. You can also see that the strip is running an animation, or not an animation, but rather a static effect. If I will increase the brightness a little bit, you can see it's receiving data, everything is working as it should. But on this SPI lamp, the yellow LED is blinking. That is an indicator for you that the data is not flowing into your SPI lamp, and also not into those SPI lamps that are next in a row. So yellow LED blinking, hopefully it's visible. Yellow LED blinking here, and also on my lamp over here. So what I have to do, take an Ethernet cable that is actually working. This is, let's double check it again, 25 meters. And as you can see, immediately yellow LED is on, not flashing, and the animation is playing on the rest of the strips. Not really sure if I mentioned this already, 100 meters is the maximum for the Ethernet cable that you can use. We've tested successfully even 350 meters, given that you'll be also using some connectors like this. You can even reach these lengths of Ethernet cable for whatever reason you might need to. However, as always, and as every time when you are working with LED pixels, it is a subject to test. I am also doing one more thing on the table. I am combining 12 volt strips, which are these three, and a 5 volt strip. And in order to do that, I have to have a separate power source for this SPI lamp. You can see that these are connected from the single power source, but then the power connection to the next one is terminated in a rather not that very pretty fashion, not very pretty way, but it's working. And I'm using a separate power source for my fourth SPI lamp. And that way you can combine even different voltages for your project if you really need to. If we will go back into the manual, which I strongly recommend that you check on our pages, you can find some schemes how you can connect the SPI lamps with the power supplies and with the controllers. So for example, in this one, you have a separate power source for each SPI lamp. So you are not doing it as the example on my table, but rather you are using a separate power supply for each SPI lamp. But you can also make a bus and connect multiple SPI lamps to a single power supply unit. There are a lot of schemes how you can, for example, inject power if you need more than one power supply for your SPI lamp because you need, okay, this is not the case, this one is. If you need more power supplies for the strip that you have connected to your SPI lamp, this is a good scheme for you to check. It is very important that you don't connect the plus from one segment to another when you are using two separate power sources. So a great source of knowledge, this manual. Also, you can find the calculator for dip switch, how to set up the proper number of pixels that you have connected onto your SPI lamp. This is also available if, for example, you have LEC 3. This is also available in the web config. If you want to find out more about web config, go to our YouTube, check out the previous training session that we had about the software. And in here, in the advanced settings, at the very bottom, you can find the dip switch calculator. So I want to set 100 on my dip switch. It will give you which pins you should turn on your SPI lamp. You can also see in the advanced settings in outputs that there is a symmetry enabled by a strip type. And we can switch the camera. It is very important that when you are working with SPI lamps that you are using SPI lamp on all four outputs, because the symmetry is allowed on all four outputs at the same time. So you cannot really combine the SPI lamp with a strip that is not connected to an SPI lamp. So basically, when you use an SPI lamp, you cannot use the remaining three outputs, for example, for strips without an SPI lamp. And this is kind of a warning in the PC or in the web config that be aware, the strip type or the symmetry is enabled by the strip type. This, you would manually change this whenever you will be working with the symmetrizer, for example. There you will turn on the symmetry manually and use it like this. Before, on this previous page, you saw that in the web config I can also set the strip type. And yes, with SPI lamp, we can switch again. You can also use an RGBW strip types. Of course, then the number of controllable pixels is decreasing, not 1024, but 768. And you can also combine RGB and RGBW strips. If I will hit test, and I will play, and I will select RGBV, you will be able to notice that if I will select white dimming, that only my RGBW strip is playing a test pattern. That is because these are only RGB, not RGBW. This might be an additional feature for you to be able to combine RGB and RGBW strips in a single project. We can change this. I think that we've covered mostly the basic settings. If you want to change what strip type you are using with the SPI lamp, you can do an update through the LEC 3. It's really very simple, and in the manual you can find the information how you can actually do this. You will create a text file with this information, where you will select which strip type you want to use, and you can only see the index of the strip type. if you will go into this table over here, you will find an index of the strip that you want to use. So, for example, this UCS 9912 whatever is supported by an SPI lamp, and I want to then use an index 8. So I will change this in my text file to 8. I will save the config file, and using the advanced settings in the web config, I will upload the file onto an SD card, reset the controller using again the web config, and once I will turn it on, the firmware will update the lamp that is connected to a output. We can switch to top-down bin. It is very important that you are doing in an update through the output on the device, not through an Ethernet switch that is on the front of the controller. And I understand that it might be confusing why I cannot connect it to this port when on SPI Lamp I have RJ45. This is not the case. It might be a little bit confusing, but make sure to remember you are always using an output to update the firmware on your SPI Lamp. So not the switch on the front. And the table with the ICs, how can we rotate this? Rotate clockwise. And the table is also in the manual, so if you, for example, don't have an access to web config, you can always double check which index, which IC you want to use, and changing it accordingly in that config file, in Notepad text file, and choose the correct one. As you can see in this column over here, most of the strips are supported by SPI Lamp, and if there is any strip that you cannot really, or IC, sorry, not a strip, if there is an IC that you can't find in the list, let us know. We will be more than happy to add support for it. We are continuously doing this over time, adding support for new strip types, because it seems that there is always a new one waiting around the corner, and we'll be more than happy, yeah, as I said, to add support for it. And there are some strip types here that are not available. However, most of those that are most common are supported. This would be, for example, if you want to set an SPI lamp to work with an RGBW strip rather than RGB. Okay, we can switch the camera to top-down then. Perfect. I will check my notes. I wanted to show you one pretty good example, and I will show you one pretty good example of or a use case where we used an SPI lamp. It was on a project in Rwanda where we did this awesome LED tree. You can see that the LED pixels or LED strips are these hanging pieces, and yeah, this is a nice one. And the way how we did this, you can read more about how we installed everything and how we basically wired everything together. You can find in the, let's see, use case, where are you? Ah, I know. Yes, can we switch to tablet then? Perfect. This you can find on our page in a download support section. For This basically is giving you in detail an information about how we build this large tree. The scheme for this tree you can find here and also here. And as you can see, there are a few circles, and on each circle there is an LEC3 controller and a bunch of SPI lamps. And on each SPI lamp we have set how many pixels there are connected. Ben, are there any questions? No? I thought there are. Okay. So on each circle there is one. Let's see. On each circle there is one LEC3 controller, and to that controller, which has 4 outputs, there are a bunch of groups of SPI lamps. So here's one, and on each SPI lamp, I will just finish, and on each SPI lamp there is one of those strings or one of those LED strips connected. And we have to be very precise in order to create this in the software, in the mapping. Tell me, Ben, what is the question? Sorry.
Thank you, Ben, for your question. So, damming slides also run on LSs? Damming like also on LEs?
DMX. Okay. We can switch on me, Ben. DMX. If I understand the question properly, thank you, by the way, whether you can use on the output on SPI lamp DMX, like you can do with LEC3 or SPI matrix, that rather than sending the SPI data to the output, you want to send DMX. This is not currently possible with this version of SPI lamp. However, hopefully in the near future we will be able to come up with a new version of the SPI lamp where this will be a feature. So it's currently in a pipeline. Hopefully it will be ready sometime this year. Thanks for the question. It's a feature that would be really nice, so hopefully we'll be able to add it very soon for the SPI lamp. If I will go back to the to that installation that we did. We've got a picture here. You can see this is only a group of 2 SPI lamps, and right now some of my colleagues is setting up on the deep switch the exact number of pixels that are connected to that particular SPI lamp. And as you can see over here, there are a bunch of LEC3 controllers installed also on this circular truss, which was then suspended, I think it was 60 meters over the audience. If you want to dive deeper for this specific use case, how we use the SPI lamp, go download it onto our page in the download section in the support. I also wanted to show you, so this would be one use case where we used an SPI lamp, and it might be an inspiration for you. Another use case would be and this is also a real-life example from one of our clients. They have a single LEC3 and they have 12 strips. I think each is 10 meters long or something like that. Let's put in 10. And the distance between the lines, this is not the most impressive arrow, okay. The distance between these lines is 5 meters. They have to go with the signal to the first line, which is my first strip. It has, I don't know, 500 pixels. In order to get the data from the first line to the second, they would have to connect the data over here. And then as the data travels, you would have to connect the end of the strip in here, and so and so. SPI Lamp helped them greatly because suddenly they were not, they did not need to connect the ends of the strips, which are pretty far away, or pretty far away from each other, 5 meters. You would have to use some, probably some buffer, maybe even symmetrizer with some kind of strips or ICs. So instead of doing this extra work, using buffers, symmetrizers, more labor, they opted for SPI lamps. And what it allowed them to do? Well, it's pretty simple. Rather than connecting these together, they have 12 strips divided into 4 outputs. So they need 3 SPI lamps for each output. They don't have to connect these. The distance from LEC3 to the strip can be 100 meters, which was the case in this scenario because they had a technical room where there was a cabling from the controller, which was rather long. So they just installed LEC3 in the technical room, installed the SPI lamps, lamp on each line, and they were good to go. SPI Lamp can be a great little gadget for permanent installation, which was the case of the club and the 12 rather long lines, or it can be a nice gadget for those installations that are not permanent. That was the case of that large pixel tree that we helped with many others to build in Rwanda. Yeah, I think that's it. Thank you very much for joining. Thank you for those of you who wrote us something hopefully nice in the chat. And next week we will have a training about LED Strip Studio software, again, this time about ArtNet. So if perhaps you are using third-party controllers and you want to use our software, it's time for you to learn something new about our program. Thanks again. Any additional questions that you might have, please send us a message, and I will be looking forward to your questions next week, Wednesday, same time, so 1600 hours Central European time, and I'm really not sure what is the date. You will see. I will send an email out. Thanks again. Have a good one. Bye.